Yesterday, we got to read a book that looks a little bit like this. It was the technology behind small appliances. And today we're going to look at another book in this series. And this is, it's right behind me. This is the technology behind amazing built structures. And this book is set up in a pretty similar fashion with our table of contents. It starts with a description of technology again, and then a little introduction about the technology behind amazing structures. And then it's organized really similarly to the book that we read yesterday, where each of the topics is presented as a question. So here are some topics in this book. How did the Egyptians build the pyramids? What is Stonehenge and who built it? What's the longest wall in the world? Who carved 4 U.S. presidents into a mountain? What is the Christ the Redeemer statue made from? Why was the Eiffel Tower built? Has the Statue of Liberty always been green? How was the Hoover Dam built? Why does the Gateway Arch sway in the wind? Whose idea was it to tunnel between Britain and France? And then there's the name of a bridge here that I'm not even going to pretend like I can pronounce. It looks like an Asian. Can the Akashi Kayoko Bridge withstand an earthquake? What is the tallest building in the world, and how long does it take for the London Eye to complete one revolution? And then I'm noticing at the bottom here, it's telling me that we're going to also have, like we did in the other book, a word watch. So words in bold will be shown and the definitions will be given in the margin, and then a web watch in case I want to learn more about that topic. And so we're going to look today with the introduction piece, the technology behind amazing built structures. Before we get started, let's take a look at the text features. Notice a photograph, Statue of Liberty right there. We've got a little caption. It says some built structures, such as the Statue of Liberty in New York, are inspirational. We have a word watch at the bottom. We're going to watch for the words monuments, pharaohs, and rivets. And then there's a little sidebar here, and it looks like the sidebar is about the people behind the technology, the people that use the technology, like architects, engineers, and a riveteer. All right, so let's see. From the moment humans began to build shelters, they have been using technology to create built structures. Humans have become fascinated with building the biggest, the longest, the largest, the heaviest, and the most amazing structures they can. Practical and inspiring structures. Many things drive people to build structures that test limits such as height and length. Often the structures they create have specific and practical purposes, such as housing people, bridging rivers, or linking two countries by road. Skyscrapers are designed to house a large number of people and businesses in small spaces, which is why the first skyscrapers were built in crowded cities, such as Chicago and New York. The Egyptian pyramids were built for a specific purpose too, as tombs for the pharaohs. Stonehenge and the Great Wall of China are other examples of ancient structures that were built for specific reasons. Sometimes the structures that people build are monuments or pieces of art. The Statue of Liberty, Christ the Redeemer, and the Eiffel Tower may not have obvious practical purposes, but they are amazing demonstrations of technology and human achievement. How did the Egyptians build the pyramids? From around 2630 BC to 1600 BC, the ancient Egyptians built large triangular structures called pyramids as tombs and monuments to their pharaohs. Archaeologists, historians, and scientists have worked out many details of how these pyramids were built, but some mysteries still remain. And then there's a nice text feature here, a photograph with the caption. Plotting the base. Egyptian pyramids have a base with 4 sides. The Egyptians always arranged the 4 sides so that 2 ran in a north-south direction and 2 ran east-west. Compasses had not been invented yet, but it is thought that the Egyptians found correct directions by placing poles in the ground to mark the shadow of the sun at certain times of the day. Leveling the ground. Before construction could begin, the ground had to be made level. One theory about how this was done is that the Egyptians cut trenches into limestone that was below the surface sand and then flooded the site with water. The water in the trenches would sit level. The workers would then cut away all the visible stone until they reached this level water line. Cutting the stone. The pyramids were made from various types of stone. Limestone was very popular, and most of it came from a quarry only 1,000 feet from where the Great Pyramid was built in Giza. In the quarry, the sand and rubble above the limestone were removed, and workers used copper and stone tools to cut slabs of rock. Long wooden levers were then forced underneath each slab, and the slab was lifted up. Ropes were tied around the slab, and the slab was placed on a sledge, transporting the stone. If the stone slabs came from a quarry near the pyramid site, workers pulled the sledge along specially constructed roadways to the site. Some highly prized stones needed to be transported hundreds of miles, so these stones were transported by boat along the Nile River. Construction. The main problem facing both the designers and builders of the pyramids was how to set the stones as the pyramid got higher. Archaeologists believe the Egyptians used a ramp system, but they disagree on the sort of ramp used. And so here we've got some kind of graphics of some possibilities of what the ramps might have looked like. This one's kind of interesting. It's like a zigzag pattern. This is probably what we traditionally think of a ramp, just kind of a straight up and down. And then we're going to skip ahead and let's take a look at something in our country, or something close to us, the Hoover Dam. How was the Hoover Dam built? The Hoover Dam was built between 1931 and 1936, providing many Americans with much-needed jobs. More than 105 million cubic feet of concrete were used to construct the dam and the nearby structures. And I love, for those of you that aren't familiar with the Hoover Dam, there's a little map of the United States telling us that the Hoover Dam is on the Colorado River, and it's located between Arizona and Nevada. Providing jobs. The land surrounding the Hoover Dam is among the hottest and driest in the United States. The dam was built to provide water to irrigate the land for farming. It was also built to generate electricity. At the time the dam was built, the United States was suffering because of the Great Depression. Jobs were hard to find, so thousands of workers flocked to the Nevada-Arizona border to work on the Hoover Dam project. The town was built to house thousands of workers, their families, and the government officials who were overseeing the dam's construction. The town was named Boulder City. And there's a nice photograph here, kind of black and white. And you can see, the caption says, thousands of workers traveled to Boulder City, and these workers dug diversion tunnels through the rocky ground, constructing the Hoover Dam. Before construction work began, tunnels were dug to divert water from the Colorado River away from the side of the dam, creating the base. Once the water was diverted, the bottom of the river had to be excavated to create the base of the dam. Mud, rock, and other materials were removed. More than 148,300,000 cubic feet of materials were excavated in the construction of the dam and the diversion tunnels, creating the concrete dam. Once the base had been created, the massive job of pouring concrete began. It was calculated that if all the concrete was poured at once, it would take 125 years for it to cool to the required temperature to harden. Instead, the dam was built as a series of interlocking concrete columns. And I love, if you look at this photograph here, you can see the scale of how far down the dam goes. This is the water behind it, so it's supporting all of that water. And that's all we're going to read about, but there's lots of cool other things in here. Statue of Liberty, Eiffel Tower, the statue Christ the Redeemer. Ooh, there is the four presidents who carved the four presidents. Into Mountain, the longest wall in the world. All kinds of good things. Tallest building in the world. A little bit about the history of skyscrapers. Here's this bridge that I couldn't pronounce earlier. Whose idea was it to tunnel between Britain and France? Gateway Arch. All kinds of good, amazing built structures.